All right, guys. We're trying to find the minimum cost to build a box. So I always like to start out with my box, length times width, length and width and height. And I just go through and kind of brainstorm all of the formulas. Volume is equal to length times width times height. And what I'd like to do is get everything in one variable. L, W, and H. They tell us that the length is twice the width. So everywhere I see L, I'm just going to replace that L with a 2W. And they also tell me that the volume is 10 centimeters cubed. And so I'm going to go ahead and plug 10 in for V, 2W in for L, and then W. And now I'm going to solve for H. And I get H is equal to 5 over 2W squared. So, or 5 over W squared. All right, so now I have everything in terms of W. The length and the height and the width. Okay, well, the bottom of the box is length times width, right? So, and the cost for that is $12. So I need to find the area of the bottom of the box and multiply that by 12 because that's what it's going to cost. So that's going to be L times W. And then I'm going to add to that, well, one of the sides of the boxes is, they cost $5, right? And so there are two sides of the box that are the length and the height. There's two faces that's the length times the height. And then the other two faces, that's going to be $5 times W times height. And there's two of those. So just so everybody understands what's going on, the base is $12. There's two sides that are calculated by multiplying the length and the height together, and that's $5. And then there's two other sides that are calculated by multiplying the width and the height, and that's $5. And so everywhere I see an L and an H, I'm just going to replace that with those values that are those expressions that I found in terms of W. So just go through and do all your substitutions and clean everything up. You get a common denominator, so it's going to be, oops. So that formula right there, that's the formula that I get, which will calculate the cost to construct the box. Okay, so let's take it over to a new sheet here. So the cost, I want to minimize the cost, so I'm going to go ahead and find the derivative of this guy. Well, that's going to be 48W minus 150 over W squared. Now I'm going to go ahead and form a single fraction, get a common denominator, and I want to find out when is this fraction equal to 0. Well, that's going to happen when the numerator is 0. So I take my numerator, I set it equal to 0, I solve for W, and I get 25 over 8. The cube root of that is approximately 1.462. Okay, that's the width that's required to minimize the cost of this box. So remember my cost equation. I'm just going to go in and I'm going to, everywhere I see a W, I'm just going to plug in 1.462, and I end up getting $153.90.